FreeBSD, a successful failure, or Linux, a failing success. Hey there, I'm Vince. Welcome to Circuit Rewind. And now that I've insulted both open source operating system communities, welcome to my series on comparing the two. Here's the TLDR. That's right, I'm giving you the conclusion firstly, so you can turn off this video and be on your merry way for the rest of your day. This series is to explain how Linux is harder to use than FreeBSD and thus more successful. Wait, how does it even work? Linux distributions are just complex enough that you'll initially struggle to figure something out. And then when you do, you'll get a little boost of dopamine from the excitement of learning something new. Each thing in Linux is just different enough that each warrant their own tutorial or article, blog, video, etc., etc. FreeBSD, on the other hand, has opted for a more stable, consistent, concise, do one thing and do it right mentality inherited from the Unix ecosystem. Today specifically, I'm talking about compiling third-party software from source. I'm going to cover 3 applications in particular, just to give a quick example, but know that what I described for FreeBSD works well and nearly exactly the same for over 30,000 packages. First on the table is a text editor. This way I can go in and quickly modify any files that I need to. Vim, Emacs. Nope, you both lose. I'm going with Nano today. For this demonstration, I'm going to install FreeBSD 13.2 from scratch. I'll get into the significance of why I'm doing this here in a bit. Pausing here for a moment, these are the only changes I'm making beyond the default FreeBSD installation configuration. I've added the ports tree and system source tree options to the installation, and we'll soon see why. Now let's continue with the installation. Let's log in as root, change directory to user ports editors nano, and then run make. The build process will ask us which optional features we want enabled or disabled with a simple menu. For now, I'm turning everything off to limit compiling dependencies since I only need the application itself. Now run make install to, well, install the application. And we have a functional Nano text editor. Let's switch from simple to complex and compile MySQL Server 8.0 next. The process is, oddly, the same. cd into user ports, databases, MySQL 8.0-server, and once again, run make. MySQL has a lot of dependencies these days, many of which have optional configuration dialogues. You can set batch equals yes when running make to avoid these dialogues, which will assume default values for each. And with all that, a complex database server program is compiled and ready to be installed. Like before, run make install. Now we can run service MySQL-server onestart to bootstrap the initial database and run the application. And now run the MySQL command to enter the MySQL console. Let's take a look at Beyond Linux from Scratch's documentation on compiling the Nano text editor. They have the URL, but no instructions on how to download the file, nor where to place it on the file system, or extract that compressed archive. There is also no information on any dependencies or setting up the compile environment. This also requires running a complicated configure command that a user wouldn't know without documentation such as this. Okay, that's a bit cheating. Let's go to Nano's actual documentation themselves and see what they say. Compiling from source. What the heck do I do now? Right off the bat, they don't say where or how to actually download the archive. However, they do show how to extract the archive using two different methods. They don't say where these files should be placed on the file system at all, though. They just expect you to know how all this works. At least in this environment, we can see that configuring, making, and installing are simpler commands. However, there is still no information on dependencies or setting up the compile environment. MariaDB is a fork of MySQL, and they have done some work to simplify the build process, but it is still not intuitive without documentation. They start off by showing how to install dependencies. However, part of this is adding a new repository, and there is no way somebody's going to remember the repository key off the top of their head. There are also complicated sed lines for setting this up as well, the way that they show it. At least it's easy for copy-pasting. When it comes time to actually building MariaDB after pulling the dependencies, they show how to actually download the code using a git clone. However, they don't say where a good location would be on the file system to put the files. One good thing is that they show to use parallel building, so you can use multiple CPU cores to do the compilation faster. Inside of their code base, they've included shell scripts for each of the operating systems to build them all in one step. Now let's continue with MySQL 8. Once again, there is no compiler information at all. There is no dependency information at all. There is no references on where to download the source archive, where to place it on the file system, but they do show at least how to extract it. They also show creating users, configuring, making, and installing the MySQL application. For Linux distributions running initd, there is also an instruction on how to install the service file for that. FreeBSD ports are most certainly easier. There is no need to set up your compile environment. It is already done for you. There is no need to manually download and extract source files. This is all handled automatically by the build scripts. And same goes for the files. There's no worry about where to place them on the file system because, again, the build scripts handle all of that for you. And same goes for dependencies. Once again, the build scripts handle all of this for you. There's no need to worry about them. All of this is automated. If you can cd into a directory and run make, you can compile thousands of programs using the FreeBSD ports collection's build scripts. But was that always the case? I tried out FreeBSD 5.4 just to check, and, well, that didn't go so well. It turns out that FreeBSD 5.4 shipped before MySQL 5.0, so I didn't have anything to use there. Instead, I switched to FreeBSD 5.5, which came out right after MySQL 5.0 did. For reference, I've never used a FreeBSD version before 9.0, which came out in 2012, before recording this video. This test is going back another 6 years to 2006 to see how FreeBSD 5.5 behaves trying to do the same thing we just did. So let's do a quick FreeBSD 5.5 release install with the same options I used for 13.2 release. The installer looks a little different, but it is functionally the same. Now I'm going to log in as root and try to compile the Nano text editor. And it doesn't work. Turns out, the website hosting the Nano source code that this version of FreeBSD is referencing no longer exists. Fancy that! Nearly 2 decades later, and websites changed? Right in the error message, however, it says where to put the source code tarball if we were to manually download it ourselves. And thankfully, Nano's website has an archive of old code tarballs. Trying again, and everything works exactly as expected this time. Nano and its dependencies are compiling perfectly now. Let's install it, and it doesn't work? This is an old shell. Let's log out, log back in. Oh, and now it's working as expected. Next, let's try the same and build MySQL 5.0 from source. Here, we run into the same issue again. Old source files are no longer on the referenced mirrors. The source files do exist on the MySQL website. However, in Oracle's infinite wisdom, they're blocking downloads from FreeBSD's fetch command. Really, guys? I downloaded the source files myself using my desktop and placed them on my local mirror. After this, everything continued as normal. And go figure, MySQL 5.0 has significantly less dependencies, compiling in much less time than 8.0. Like before, make install to, well, install. Now let's start the MySQL server and log into the MySQL console. Stability in a system is usually measured whether it crashes or not, but I'm here to argue that stability also means predictability. The simple instructions on how to compile software on FreeBSD today were the same 17 years ago. Putting aside the fact that the mirrors today didn't have the files that we needed, so we had to go download a couple things manually. It would have worked 17 years ago when it was released. But who cares about 17-year-old software today? Quite honestly, this argument is the exact opposite. What about 17 years from now in the year 2040? Do you think these instructions will still hold true then as they do today? Probably yes. Do you think the Linux instructions presented today will hold true even 5 years from now? Press X to doubt. As third-party software changes in the Linux ecosystem, new blog articles need to be written, documentation updated, people asking questions to one another to figure out how things work, going on forums, going on Reddit, going on social media. And then the instructions are different for each and individual application, like we just saw with these examples. And then there are organizations like Red Hat and Canonical, which have a financial vested interest to keep things just hard enough so they can sell you support contracts and sell engineers on certifications. In contrast with FreeBSD, when third-party software changes, instead of writing new articles or updating documentation, the engineers go and update the ports collection build scripts. The end user experience remains the same, not only from time to time, as we saw, but also from software project to software project. And this holds true for over 30,000 other software packages as well. And these consistencies remain stable for decades. There is no need for tutorials or updated documentation. There is no need to go on a forum and post asking questions. There's no need to go on social media to see what people are saying. This leads to less articles, less discussion, less promotion, less search engine rankings, and ultimately less visibility for the FreeBSD project as a whole. FreeBSD's engineering success overall is one of the key reasons for its overall industry failures. And conversely, Linux's engineering failures is one of the key reasons to its global success. A little side note, I wasn't looking at the date and didn't realize that today was FreeBSD's 30th birthday. What a great way to celebrate this day by publishing this video. The whole premise of this video at the end, as you saw, is that we need more people talking about FreeBSD, which I'm doing right now. And it's hard to do that because it is so stable. So hopefully you like this video, you'll give it a share, thumbs up, whatever, and I will leave you with some birthday fireworks.